Okay, we are working on Study Guide Assessment Module 2, Exponents and Scientific Notation. And here's the crux of what we've been talking about. If you have a really big number like 26 billion, we have an agreement that a shortcut to write this is called scientific notation. If I translate this into scientific notation, I take these digits and I create a number that's greater than or equal to 1 and at the same time less than 10. So when I look at these digits, I see if I take these digits and I put a decimal right here, that number becomes 2.6, and 2.6 is greater than or equal to 1 and less than 10. So I'm going to write 2.6 here. But as you can see, this number is way, way, way bigger than this number. I need this number to be equal to this number, so I have to multiply it by a power of 10 that will make it equal to this number right here. Now I could multiply that times, oh my goodness, a trillion, I guess, to get 26 trillion. Would have to be 10 trillion. But a better way to do this is multiply it by a power of 10 that tells me that I need to move this decimal to the right. Let's see, if I have my decimal here, I'm going to have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I'm going to write this 10 to the 10th power. A positive exponent means my number is getting bigger. This means I moved my decimal to the right 10 times. Every time I move my decimal one place to the right, the number gets 10 times bigger. If I move it twice, my number gets 100 times bigger. 3 times, it gets 1,000 times bigger. 4 times, it gets 10,000 times bigger, etc. So this number is actually 2.6 times 10 to the 10th power. So if we are working with really big or really small numbers all the time that have a ton of zeros in them, this is a much simpler way to write those numbers. So in your study guide, you are asked to write these following in scientific notation. Well, this is 8,904. So I know if I put my decimal here, it becomes 8.904. 8.904 is greater than 1, and it's less than 10. So I'm going to write 8.904. Now, what do I have to multiply that to get the decimal from here back to the end? Because there's a decimal here. Even though we don't see it, we know there's a decimal at the end of the number. So to get the decimal back to the end, I need to move this 1, 2, 3 spaces to the right. So it's 8.904 times 10 to the positive 3 power. All right, this number right here, 27,150,000. I am going to take these 4 digits right here, 2715, and make a number that's greater than 1 and less than 10. And that number would be 2.715. And in order to get this decimal back to the end of the number where it was in the first place, I would have to move the decimal 1, 2, 3, 4, 5, 6, 7 times to the right. So I'm going to multiply this by 10 to the power of 7, and that number just got that much bigger. This is equal to this. Every time I move a decimal, my number just got 10 times bigger than it was before. Okay, this one is a very small number. We're going to do the exact same thing. I'm going to take the digits 9, 1, and 3, and I'm going to make a number greater than 1 and less than 10. But this time, 9.13 is bigger than this number right here. This is a tiny, 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 tiny number. So what I'm going to do is I have to move my decimal backwards to make this number smaller like this number. So if my decimal is between the 9 and the 1, I'm going to move it to the left 1, 2, 3, 4, 5 times. So it's times 10 to the, now if I multiplied it times 10 to the 5th, that means I would be moving my decimal to the right and it would be getting bigger. I need to move my decimal this way to make the number small like this one. So I'm going to put to the negative 5 power. That means I move my decimal left 5 spaces. And lastly, another small number. I'm going to take these 4 digits, 1502. I'm going to make a number that's greater than 1 and less than 10. That's 1.502. And I'm going to multiply this by, okay, let's see, if my decimal is here, I put the decimal between the 1 and the 5, I'm going to have to go 1, 2, 3 spaces to the left to get this number to look like this again. I need to make this number smaller. I'm going to move my decimal to the left, and that means I'm going to multiply it by the negative 3rd power. Is this written in scientific notation? Why or why not? Well, it looks like it, but this number is not greater, well, it is greater than 1, but is it less than 10? No, it is not. So what I would have to do is move my decimal back here 1 space so that 2 7/78 is more than 1 and less than 10. But then I would have to compensate by saying, since this number became 10 times smaller, I'm going to have to make this 10 times bigger. So this would be 10 to the 3rd power. In other words, if I wrote this out in standard notation, I would have my 2, my 7, and my 8. If my decimal is here and I'm raising it to the 2nd power, I would move it 2 spaces to the right, and my number would be 2,780. Now all I did here was rewrite this number in scientific notation. These should be equal. I'm just writing it a different way, a way that mathematicians have agreed to express their numbers. So that means I made that first number more than 1 and less than 10. And my decimal's here. Now I'm going to move it 1, 2, 3 spaces to the right. Put my 0 here. These numbers are equal. These should be equal because these are equal. All I did was change this to a number that's greater than 1 and less than 10, and at the same time I adjusted my exponent accordingly so that this number is equal to this number. So I didn't change the value of the number. These are still equal to one another. I just changed the form, the way that it's written. I changed it to scientific notation. Okay, here's one more real quick, and then I'll end this video and start another one. 213 million equals 2.13. So there's my number that's greater than 1 and less than 10. Now I have to move this decimal from here back to the end, just like this one is. If the decimal's here, how many spaces do I have to move it to get it back to the end? I have to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. 8 spaces to the right because I need this number to get bigger. I need my decimal to go to the right, 10 to the 8th power. Okay, that's it for this video.